dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Good morning and I welcome you to this tutorial. In our last tutorial we looked at gases in the atmosphere, and today I want us to have a recap of electrolysis. When you talk about electrolysis, we mean the decomposition of a compound by passing electric current through the compound. Decomposition means breaking it down. And in electrolysis, we have some terms we use. For example, we have what we call electrolyte. Electrolyte means an ionic compound that can conduct electricity either in molten state or in solution form. Then we have what we call an electrode. An electrode is a rod which can be made up of metals or graphite, through which electric current can flow into or out of the electrolyte in an electrolytic cell. Then we have what we call anode. Anode is a positive electrode of an electrolysis cell. You know, a cell has terminals, a positive and a negative terminal. But in an electrolytic cell, the positive terminal is what you call the anode. Then we have what we call the anion, which is a negatively charged ion, which is always attracted to the anode. You know that negative ions always move to the positive terminal. Then the cathode is the negative electrode of an electrolytic cell. And then the cations are the positively charged ions, which is attracted to the cathode. Then we have this example of an electrolytic cell. This is how an electrolytic cell looks like. This is our cell, and then here, this is an electrolyte now. That's the electrolyte, and then this is the cell, and then these are the electrodes. Whereby these two are the electrodes. One is the anode, another one is the cathode. Then we come to an example of electrolysis of molten compounds. Molten, we mean a compound which is solid. You heat it, and then it melts and becomes a liquid, then you electrolyze it. For example, in this case, I'll use I have my electrolytic cell here. I'll draw a similar cell. These are the electrodes. So this is heat. I have to heat my compound so that it can melt. And my electrolyte is now known. It is led to bromide. This is a bulb. That's a bulb. This is the cell. This is my anode. Then the cathode. So what happens that during electrolysis of this compound, nothing will be observed before this electrolyte melts. So before I heat, I will not have any observation. Even this bulb will not light. But when I heat and the electrolyte melts, that means the ions now will be free to move. So the bulb will light, and I will begin to see bubbles of a brown gas, and that gas is going to be bromine at the anode. Then at the cathode, nothing much will be observable, but you will see lead, a gray substance forming at the bottom. Then when you stop heating, everything will stop, because this lead to bromide will solidify and ions will no longer be able to move. So electrolysis will stop because the circuit cannot be completed. We come to observations we make during this electrolysis. One, I've already said that before you melt the electrolyte, no observation will be made. But after melting, the bulb will light, you will see bubbles of brown gas being given off at the anode. Metallic lead will form underneath the cathode. And when you stop heating, the lead to bromide will solidify again and everything will stop. That means that will mark the end of electrolysis. Reason, we say that the reason why there is no observable change before you melt the electrolyte is because ions are not free to move. And because they are not free to move, the circuit is incomplete. That's why the bulb cannot light. Then when you melt, the ions become free to move and the circuit is completed. In other words, electrolysis occurs and even the bulb will light. And the bubbles of the brown bromine form at the anode because bromide ions, which are the negative ions, always are attracted to the anode, and when they reach the anode they get oxidized, they lose electrons, and then they form bromine gas. Then we said when you stop heating, everything stops, electrolysis stops, because the lead to bromide solidifies and the ions are no longer free to move. So the circuit becomes incomplete again and electrolysis stops. Then we come to reactions at the electrodes. When you look at our electrodes, and here the bromide ions, as you can see, we have that is at the anode. You can see that these bromide ions, I'm using the state of liquid because it's molten. This will lose an electron, and then we'll have this. But because bromine is diatomic, one atom cannot remain as bromine, so I'll have two of them giving me bromine, and then 2 electrons, then this is going to be a gas. That's why you'll see the bubbles. Then at the cathode, that is the negative electrode. Always positive ions move to the negative electrode. We'll have the the lead ions. Still, I use a state of liquid because it is molten. These will gain electrons, and then we'll have lead metal, which is going to form at the bottom of the cathode. Then we come to electrolysis and redox. We all know that a redox reaction is a reaction where both oxidation and reduction occur at the same time. And we know that during electrolysis, as we have already seen, that always at the anode there is oxidation, loss of electrons. The negative ions lose electrons, and at the cathode there is reduction. Positive ions gain electrons. So meaning that during electrolysis, both oxidation and reduction occur. That's why we say that electrolysis is a redox reaction. Because at the anode, oxidation occurs, negative ions lose electrons, while at the cathode, reduction occurs because the positive ions gain electrons.